Hey guys, so today we're going to do section 4.2, part 2. If you remember back in geometry, SOHCAHTOA, over there on the right hand side there, that is just the ratios for sine, cosine, and tangent of an angle of a right triangle. So these three angle measurements here, this angle, the sine of that angle is the opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Notice the adjacent side is the side that connects the angle to the right angle. So it's the side length between the angle and the right angle. We're going to focus on when the angles are in the bottom left, and then the right just shows you the difference of when your angle's up top here, the opposite becomes the side length on the bottom. So for our unit circle, the radius is 1, and for all of our triangles, that means that our hypotenuse is 1. So 30 degrees here, our hypotenuse is 1, and our side lengths, opposite is 1/2, and adjacent is √3 over 2. And for the 45, 45, 90, that was the easier one to remember because the side lengths are both √2 over 2 since it's an isosceles right triangle with an hypotenuse of 1. So looking back at finding sine, cosine, and tangent of 30 degrees. So let's just focus on as if our angle is 30 degrees. So sine of 30 degrees is opposite over hypotenuse. So opposite is 1/2 over our hypotenuse. Oh, sweet. Our hypotenuse is 1. So that is awesome because 1/2 divided by 1 is just 1/2. So we don't need to worry about dividing by 1. For cosine of 30 degrees, it's adjacent, √3 over 2, over hypotenuse, which is 1. So we don't need to put over 1 because we know that that's just going to be the original numerator. Tangent of 30 degrees is opposite 1/2 divided by adjacent √3 over 2. So for this one, we have a little bit of work to do. Trying to make room here. Let's see if I can get that. So this one here, that means 1/2 divided by √3 over 2. When you divide by a fraction, you flip the divisor and change it to multiplication. The 2's cancel, and you're left with 1 over √3. Unfortunately, we have to rationalize by multiplying top and bottom by √3 over 3. So this will be √3 over 3. So the tangent of 30 degrees is √3 over 3. So we have a little bit of work to do for those ones. Sine and cosine are nice because sine is just this value, the opposite length, and cosine is just the adjacent length. All right, let's do the 45 degree ones. So sine of 45 degrees. Let's focus on this angle right here. Opposite. So that is √2 over 2 over hypotenuse, and the hypotenuse is 1, so the same thing. We get to leave it just as the opposite. Cosine of 45 degrees is adjacent over hypotenuse, but since the hypotenuse is 1, we can just focus on the adjacent side. Tangent is of 45 degrees is opposite √2 over 2 divided by, I'm running out of room here. Let's see if I can move down a little bit. So √2 over 2 divided by √2 over 2. Why is that nice? Anything divided by itself is equal to 1. So the tangent of 45 degrees, this one's nicer. It is 1. So for dealing with angles on our unit circle, we just saw how nice it is that we don't need to worry about the hypotenuse because the hypotenuse is 1. So sine of 30 is 1/2, cosine of 30 is √3 over 2. Tangent of 30, we have a little bit of math to do, but it is √3 over 3. For sine, cosine, and tangent of 45 degrees, √2 over 2, √2 over 2, and 1. So let's write down this definition here. Someone, after studying for a long time on the unit circle here, let t be the real number on the unit circle corresponding to t. So instead of using angles, they're using the letter T to represent the angle. So hit pause and write down these 6 definitions here. All right, we have 3 new trig functions. They are the reciprocal functions. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So we're going to need to remember those 6. Notice the S's don't match up. Cosecant starts with a C. That one is matched up with sine. So just be careful whenever you're writing them. All right, on the right-hand side is our lovely, nifty unit circle filled in. And on the left-hand side, we are going to evaluate our trig functions now. We're going to evaluate the trig functions for angles that are no longer in degrees, but in radians, but we're going to help, our unit circle is going to help us to determine those values. All right, so let's look at part A to start. So I'm setting up my 6 trig functions for pi over 6. We're going to use this box up here to help us, and also our unit circle. So pi over 6, locate pi over 6 on your unit circle, which is right here, and we're going to need the point that comes with it. So the sine of pi over 6, by definition up here, the sine of your angle is just going to be the y value of your angle. So this one, our y value over here is 1/2. The cosine is our x value, √3/2. The tangent is y divided by x. So that is 1/2 divided by √3/2. Simplifying this, we just did this exact one earlier. You flip √3/2, so 2/√3. You need to rationalize because this is 1/√3, so this will simplify to √3/3. So I always do the original 3 first, because then these ones over here, the reciprocal functions, we just take the reciprocal of sine, cosine, and tangent. So cosecant is the reciprocal of sine, so you flip this one, so 2/1. So the cosecant of pi over 6 is just 2. The secant of pi over 2 is the reciprocal of 2√3. We're going to have to get really good at rationalizing our denominators. So this comes out to 2√3/3. And the cotangent. Tangent was 1 divided by √3 before we rationalized, so the reciprocal of 1/√3 is √3/1, which is just √3. Let's take a minute. Go back to our angle here. Pi over 6 was and is 30 degrees. Going back up, we were dealing with sine, cosine, and tangent of 30 degrees up here. 1/2, √3/2, and √3/3. It's the exact same thing. It's the exact same angle. But now using the unit circle, we're going to allow the values of x and y from our points, √3/2, 1/2, to help us evaluate our angles in radian measure. All right, we are going to do part B. I need to make some room here, so I'm going to erase this example. So if you need to, hit pause and take a screenshot of this, or hit pause and fill in all of the answers for this one. All right, let's take a minute and do when our the 6 trig functions of our angle when our angle is 5 pi over 4. Let's use a different color here so it stands out. So we are doing 5 pi over 4. So looking at our unit circle, 5 pi over 4 is all the way down here at 225 degrees, and those are our x, y values here. So we're going to be using -√2/2 and -√2/2 as our x and y values for 5 pi over 4. We're still focusing on this definition box up here for our 6 trig functions. All right, so sine is our y value. So sine of 5 pi over 4, our y value is -√2/2. Cosine is our x value, which is also -√2/2. And tangent is y over x. So -√2/2 divided by -√2/2, that equals 1. That's not too bad. Okay, cosecant, secant, and cotangent, we are going to be using the reciprocal. So the reciprocal of negative root 2 over 2. This means the same thing as negative 1 over root 2. But we always write this as a simplified. So the reciprocal of something rationalized, think back to what it would be without being rationalized. So the reciprocal of 1 over the square root of 2 is the square root of 2. Since it's negative, we need a negative sign. You can flip 2 over root 2 here, and then you have to rationalize 2 root 2 over 2, and then the 2's cancel. I always find it easier just to know the reciprocal of something rationalized is just going to be the square root itself. All right, so that is negative root 2. All right, secant. The reciprocal of this was the same as the reciprocal of that because these two are equal. So this is also negative root 2. Cotangent, you can do cosecant divided by secant, or just look at the reciprocal of tangent, which is just 1. So that answer is 1. Hit pause and take a look at those 6 answers here. All right, now let's move on to part C. All right, so now we're looking at the angle pi. So that one is going to be over here at 180 degrees. All right, so our point we were focusing on is negative 1 comma 0. That'll be interesting. All right, so the sine of pi is 0, our y value. Cosine is, or x value, negative 1. And tangent is y over x, so that simplifies to 0. Here is the tricky part. Cosecant of pi. Cosecant is the reciprocal of sine, or 1 divided by y. So a lot of people get confused when they try to do the reciprocal of 0 and they mindlessly write down 0. Be careful. This is 1 divided by your y value, which is 0. That cannot happen, so you write undefined whenever you have to do a reciprocal of 0. Hit pause and make note of that. The secant, the reciprocal of negative 1 is negative 1. And the reciprocal of tangent, which was 1 over negative, or 0 over negative 1, would be negative 1 over 0. So that also is undefined. So you can get undefined as your answers for these ones. All right, the last example we are going to do is part D, when our angle is negative pi over 3. Okay, so negative pi over 3. So on our unit circle, we don't have any negative angles, but we know about coterminal angles. So negative pi over 3, you would have to go in the in the clockwise position down to 1 pi over 3, which is right here, which is at 5 pi over 3. So we are actually going to be using this angle measurement and this point because negative pi over 3, it's coterminal angle, which means it has the same exact point. It lands on the terminal side with the point 1/2 comma negative root 3 over 2. That would be the same exact thing if I asked you the question of find the 6 trig functions of 5 pi over 3. So hit pause and try to do this problem right here without me going through it all. All right, so this one would be negative root 3 over 2. This one would be positive 1/2. This would be negative root 3 over 2 divided by 1/2, which ends up being negative root 3. The reciprocals here, this one's the easiest one because that'll just be 2. You have to rationalize because this will be negative 2 over root 3, which rationalizing negative 2 root 3 over 3. And this one, the reciprocal of negative root 3 will be negative root 3 over 3. Takes a little bit of practice to get used to rationalizing, but those would be the 6 answers of your trig function here. Hit pause if you need to take a look at my work. All right. Last thing, I would like you to hit pause and do these 4 angles for your checkpoint. You are finding the 6 trig functions of all 4 of these angles. So you should make a chart like up here for each of your angles. So you're going to get 6 answers for each of these 4 angles here. So do that and bring it to class for us to go over it next class. Let me know if you guys have any questions. Have a great day.